my biases, and you don't want that. You'd like to see some of the things that you want to show. We ready to go, Pete?
Yeah.
Okay. So I want to start with the cold pool analysis. I won't do this every week, but this week's been kind of interesting. It's been a chilly week here in town. Departures for the daily temperature have been on the order of 3 or 4, and sometimes 5 degrees below normal. But the month is still just fractionally below normal as we get to the 29th, and tomorrow will be, of course, the last day of the month. So it's not been a particularly cold September here. It's just been a cold week to end the month, as we've seen. This is the aerial extent of the -5 air at 850 millibars over the whole northern hemisphere. And we started out the month well below the long-term average. And in fact, one of the days tied the all-time record for lowest extent. I think that was September 6th. But since then, the hemisphere has cooled off rather rapidly. In fact, if you think about the slope of this line, a collection of lines, which are the average over several different intervals, September and October are the fastest increase of the cold air pool's aerial extent of the entire year, as it turns out. You can see it kind of flattens out in November into December, and then December itself is even flatter than that. So we're at the period of time in the year where the cold pool is expanding most rapidly in terms of its area per day. And since about the 6th of September, it's expanded at a rate that far exceeds the climatological average. So the last 3+ weeks of September have been unusually chilly over the northern hemisphere by this kind of obscure metric. And we've now, just in the last few days, approached a period of time, almost a whole week, where it's been just about the average rate of increase, and we find ourselves squarely on the 29th on the 1948 to 2014 average of the aerial extent. So we're kind of where we should be for this time of year, despite the slow start. And even though we've had, the last 7 to 10 days, we've kind of picked up the pace and gotten ourselves back to normal, we are still looking at the 10th warmest September up through the 29th of the last 74 years, which is kind of interesting. I wouldn't have guessed that by this diagram. It doesn't look like this integrated departure is that large now that we've made headway back to normal. But it is. It's still the 10th warmest September, so that's unusual. Okay. The reason why this is kind of a good place to start our discussion is because it's kind of related to where we're going to end the discussion today, because I wanted to say a little bit about the forecast for next week. And one of the elements that will be a sort of a high-profile element of next week's forecast is how cold it's going to get next Thursday. It's going to be really chilly. First legitimate cold air outbreak of the year. And if it were at another time of year, it would be really miserable. As it is now, it's going to be noteworthy. And it'll probably do some work to changing the leaves if the temperature does anything about that. I'm not sure about the biology. But anyway, it'll be interesting to see where we are a week from now. I probably won't bring this in every week, as I said, and probably not next week, unless it really just kind of climbs above this average, which would give us a period of really exceptional cooling over the hemisphere. And I don't have a sense of whether or not this rate of cooling is exceptional, but it is unusual, it looks like, because it doesn't happen. You can't get an average that's got a lesser slope if you have lots of events with a steeper slope. Okay. So that's it for the cold pool. I wanted to then talk about, I think you've probably heard about this Hurricane Ian. It's been a pretty remarkable event. We can get rid of my mail. I'll get it out of there in a minute. Let's start with our regular overview, Pete. So Pete's produced this beautiful infrared imagery across the whole, I think this whole week. And you can see that tropical convective cluster that turns into Ian south of Cuba, and here's Jamaica. And you're kind of watching this whole thing get together, and there's kind of the beginnings of the circulation to the south of the western part of Cuba, and it kind of exploded. I think it was a Category 1 storm when it was meeting the high terrain here of western Cuba, but that didn't do much to disturb its progress. You can see the eye beginning to emerge just before it gets to Cuba, and then it doesn't really even disappear over that high terrain, which is remarkable. Comes off the other side and really goes to town. And there's been a lot of scuttlebutt discussion today and yesterday about how, the ECMWF forecast had it closer to Sanibel Island than Fort Myers and this, that, or the other thing. But I haven't said this publicly, in the Albany map list, but I really feel like I should. Nobody in Southwest Florida was caught by surprise by this thing. So does it really matter anymore about exactly where the thing makes landfall? In terms of getting preparedness? So, we talk a lot in our science about how, and it's with good cause, we're doing a lot of important work to make sense for citizens of our country and other countries of what's going to happen in their location. But really, if we're arguing about a 50-kilometer difference between landfall in the European model and all of the models from the US, who cares? Nobody was caught by surprise by this storm. So I think the resources involved in that argument really ought to be put somewhere else. We have bigger problems that the community of scientists and social scientists combined could work to solve than that little bit of a problem. So anyway, that's my little soapbox on that. I think we really should kind of recalibrate what we argue about in our field when it comes to these things. This was a remarkable forecast. And the other thing is, it's no longer surprising that it's this accurate. It's just no longer surprising that you're going to be able to say 4 days in advance, from St. Pete down to Fort Myers, watch out, start taking precautions. And even people who seem to be reluctant to believe science, I won't mention names, but one of them is governor of the state of Florida, seemed ready to take the advice of the scientists at T-minus 5 days. And good for him in doing that. Okay, so that probably saved a lot of misery. It didn't eliminate the misery, but certainly it saved a lot of it from this event. So this is one of the things that struck me about looking at some of the, look at that, right over Sanibel Island. One of the things that struck me about looking at the damage in Southwest Florida was that it reminded me so much of Maria in September 2017 over Puerto Rico. Widespread regions that looked like tornadoes had run through there over enormous areas. I mean, remember that, the denuded trees in Puerto Rico? It was just stunning to see those pictures. And the same kind of thing appears to have now happened in Southwest Florida. So we've got these beastly storms that we need to contend with occasionally. So now it'll be interesting to see what will happen in the relief efforts. I sure hope that they go well. So if we can speed up quickly, Pete, we'll just take a look at the late part of this evolution as it makes landfall. And here, last night it looked like landfall was going to be right in Charleston. Now it's going to be a little further north than there. Actually, it's probably happening right now, isn't it? So a little bit further north than there. That does matter, of course. People in Charleston will be spared the brunt of a Category 1 hurricane, but places just up to the north toward Myrtle Beach will get it a little bit worse, a little bit more coastal flooding and all that. So that these differences that I'm talking about in the forecast are not without consequence. But I have the opinion that we shouldn't be overly critical of ourselves at this stage. I think we're providing the right kind of guidance for citizens. So here comes Ian. I think it's still a Category 1, just as it made landfall, but the maximum winds were almost 90 miles per hour. It was sustained winds were 90 miles per hour. And huge amounts of rain, we'll take a look at that. That's coming 3 to 5 inches of rain widespread over the Carolinas. Some of it in hilly country. Much of western South Carolina is pretty hilly. And so there's going to be big impacts in both the Carolinas, southern Virginia, and that might be the extent of the really serious impacts from what remains after today of Ian. Now, one thing that's different about Ian with respect to the last 2 Fridays, we've just had 3 Fridays in a row of tropical cyclones of really importance. The last 2 have been picked up strongly by the mid-latitudes and turned into beastly events at high latitude. This one does not appear as though it will do that. Look at how that eye survived across the transect of Cuba. Here it comes. Looks a little wider perhaps because you're just missing out on the radar range, and then when you get closer in it gets a little tighter. But the other thing about Ian is that it's an enormous storm. And I don't think it caught the scientists by surprise, but in terms of the Federal Emergency Management Agency and other people who are working for relief, the widespread nature of the extraordinary rains. I think there was a 31-inch total in northeastern Florida. I can't remember the name of the town. And that was nowhere near landfall. So all the way across the peninsula, rain totals were exceeded anything that they've ever seen before. And the governor correctly said this was the worst flooding the state's ever seen. And it's from this incredible storm. Just sat over warm water for a period of time to intensify. That heavy rains. There were tornadoes. There always are. That's I don't know how many. Do you have any idea how many?
I don't know how many, but I was going to comment there were, some pretty significant tornadoes, and I think at least one was rated EF2.
At landfall, there were tornadoes in the Fort Lauderdale area.
Yeah.
So I mean, that's all the way across the state.
Crazy.
Hundreds of miles to the northeast. So And I don't know what's happening today in the Carolinas, but I wouldn't be surprised if there's tornadic activity there too, to just sprinkle in a little more disaster on top of everything else that's gonna happen. And this is now the storm total precipitation, as estimated by the NEXRAD. And so just to get you calibrated, these pinks are in the 14 to 16 inch range, okay? And then when you get to the dark purples, way up there, or I guess the lighter purples in there, right there south of St. Tampa, that's in the 24 inch range. So there's your sash of extraordinary rainfalls across the state of Florida. And I think Okeechobee just stands out as that nobody's observing it over the giant lake, so that's the only reason there's that spot. And then you're gonna get more, nothing like what was in Florida, it doesn't look like, over the Carolinas, but still heavy precipitation there, and maybe underestimates now 3 to 5, it might be more than that. So a very interesting storm, without any doubt about that. I want to show something from, I think I got this from, what's the site that where you can do the cross sections? I think it's Tropical. Yeah.
Isaac, I was gonna say, Isaac had his hand up in his.
Oh, yeah.
Oh, no, I was just gonna say, you had mentioned Lake Okeechobee, there was a pretty cool, after landfall, the southeast part of Ian kind of got sheared away. Like you could see as the southeast always traveled over Lake Okeechobee, you could see some, what I would assume to be lake-induced, not necessarily induced, but augmented precipitation come right off Lake Okeechobee. It was cool to.
Might have just been spray being blown and then
Yeah.
accumulating in somebody's rain gauge, literally, I mean, that could be the case. You know, I don't know if it actually got processed as precipitation in some instances, but yeah, pretty unbelievable. What an amazing event. If we can go to, yeah, it is tropical tidbits, I can draw the cross sections, right? I want to show you the structure of Ian right now in terms of the, the canonical PV tower structure of a tropical cyclone. So we'll look at the 6-hour forecast from the 12Z run this morning. That's the right run, so that's 6 hours. I think we may even be there. Okay, let's draw a cross section right through like that, Pete. And I think you use control and the right mouse button. Okay, so that's about right through the middle of the storm. And let's go to the PV, and we'll take a look at this. So here's look at how dilapidated that is. This still shows the the genetic makeup of a tropical storm. So here's this PV tower in the middle, and these are winds astride it. So into the page is dashed, and out of the page I think is solid. And so it goes up to, in a scraggly way, up to about 300 millibars. That's what the PV tower looks like now. But theta shows, at least in the upper troposphere, a really obvious warm core, and then it kind of gets a little bit tilted and maybe disrupted in the middle. So this is what a tropical cyclone looks like when it's ragged and about to expire as a tropical disturbance. No disrespect, Ian. Now, let's go back to Tuesday, 12Z. Let's look at that run. Yeah, right there, and look at the 6-hour forecast on that. That's when the storm was, actually, let's go a little ahead. Maybe I have the wrong time here. Let's go to the next run.
Wednesday morning, right before it hit.
Yeah, I was trying to get it right before it came on landfall. I thought I wrote that down here. Oh, 12Z28, yeah, that's right. Okay, so that's the one. Now let's draw a cross-section through it, just like you did. Okay, perfect. Now take a look at this in the PV. That's what they look like when they're ready to roll. I mean, these values are in the 5 to 8, 9 PVU range. They're not equaled until you get into the tropical tropopause level above it. Look at the theta, the warm core is exactly vertical, and then extraordinary winds astride it. I think you're talking 80 knots on both sides when you look at it. But the key thing is, look at that PV tower, and it goes up to 200-ish millibars, not dilapidated, straight vertical. It's like a concrete obelisk of PV. And so there's a nice characterization of what the storm looked like just about before it hit Sanibel Island, and what it looked like in the other picture when it's just about to make landfall on the South Carolina coast. It's still a potent thing, and it should not be considered a wimpy storm, but it's wimpier than it was. There's no doubt about that. And there's one very quick way to take a look at that, okay? And then let's also take a look at the projected rainfalls, Pete. I think this is a good place to do that. We can, yeah, there is total accumulated precipitation. Let's start on the 12Z run from this morning, so that'll be right there. and then just step through. So here's when it's making landfall. This is a 6-hour forecast valid about now. So from Charleston toward Myrtle Beach, you're already in the 4-ish inches total accumulation range, and you're in the 1 to 2 here in the rest of North Carolina and South Carolina. So let's step forward a couple of times. You can see that area of really substantial forecasted precipitation expands. The Appalachians run right about here in western North Carolina. So this isn't particularly hilly. This is Research Triangle area, Raleigh, Durham, and then further west. But when you get up into West Virginia and western Virginia itself, that's Appalachia. So that's heavy rain in very mountainous territory, and then some heavy rain off the coast. We can keep going a little bit. You'll see that it stops adding in the Virginias in Carolina. So it's all now new precipitation as other processes take over off the Atlantic coast. So that's the extent of the current forecasted precipitation. So the dark purple is around 4.5 to 5 inches of rain in fairly high terrain. I'm not sure that that'll be enough. I have a feeling you'll get isolated values larger than that. But the storm does, we go to sea level pressure field, if we could. And then let's go back to the beginning. Just this one here is good enough, Pete, thanks. And then we can go back to the beginning. Since this is already on Monday. So the storm is going to, and we just step through, the storm is going to decay fairly rapidly. That's 984 millibars to begin, 1,003 over Raleigh by midday tomorrow. And then it's very hard to find the center of circulation, or at least a closed isobar that would indicate the center of circulation of what used to be Ian. So it gets shredded by the Appalachian Mountains fairly quickly. But that doesn't mean it won't be precipitating. So if you're in the so-called Happy Valley of State College, it's going to be a cloudy, it's always cloudy, rainy valley there this weekend. I don't know if the Nittany Lions or whatever they're called are playing at home this weekend, but they're not going to really enjoy it. Well, it doesn't matter. Whoever they play, they don't enjoy it. Okay, so that's the situation that I was ready to talk about with respect to Ian. Does anybody else have any other comments or tidbits of stuff that they've heard about the storm that they want to share?
In the profiles, did you see the Hurricane Hunter profiles right before
No.
Ian was going to make landfall?
How can we-
Technically, the lines are just like so close.
Yeah.
It's one of the scariest profiles I've ever seen.
Do you know where to get it?
I think I retweeted it. I retweeted it.
Go to aircraft recon.
Yeah, and you can do the aircraft, yeah.
Oh, right here?
Oh, yeah, right there.
6 hours?
And then how do we, I don't know how to navigate around here, Myra, so maybe you can help us do that.
It's only about 6.
They don't store them on the site?
Yeah, I'm not, oh, right there. Most recent drop zone soundings, maybe you can go.
Oh, okay.
if
And
you-
we're looking at temperature and dew point on a pseudo AMAT, I think, right? Or-
Yeah.
Okay. And this is,
This is recent.
this is
might
in
be-
the
I might
eye.
need to go a little.
Yeah,
Wow.
Keep scrolling.
see, look
This is very cool. I didn't know this existed.
I don't know if we can go back far enough.
at- yeah, actually, Hurricane Hunters had a scare.
Oh, that's right. I'd heard just a
during one of
little
these
bit about
soundings. They
that.
went down and they actually had to like fly around the eye and then go back early.
Is that right?
Yeah, because they
Yeah,
said
I saw-
it was the worst flight that they've ever been, well, the ones that have done this for a long time, so.
Yeah, there was some video.
This is the
that
one you were
somebody
supposed to be
tweeted
on?
Not that, I was supposed to be on the next one, I
Oh.
think. That would've been a little scary.
What
I saw-
happened?
Miss Piggy was having some maintenance issues.
Oh,
so
yeah, it was Kermit, the one
Yeah,
that
yeah.
suffered, yeah.
But I saw in
Yikes.
that thread that they were at like a 15-degree angle of attack or something and still couldn't get any lift. They were still just falling, which is horrifying.
Oh.
Yeah, it was like over 1,000 feet,
Yeah.
like in seconds.
They had
Oh
hail
my
damage
God.
on the nose cone too, which is, only happens in
Yikes.
incredibly strong TCs.
So was the nature of the profiles, we can't find the ones that caught your eye, Myra, it was the nature of the wind speeds, or what was the
It
characteristic?
was just, yeah, I'm gonna say it's one of the scariest profiles I've ever seen, like for the entire hurricane transit before it hit
Yeah.
the southern Florida. I think they only keep the most recent ones, but it's technically like a straight, they're so overimposed, it's almost like a straight line looking at both of them together.
Oh
It's
my
just-
God,
yeah.
unbelievable. Wow.
Yeah.
Yeah, I heard about that flight, but I didn't know kind of what that really meant, in the sense of how scary it was for the veterans, but I guess they were really scared. Wow, unbelievable.
Would you go back to the satellite really quick? eastest of it. I thought there was kind of a little bit of an extratropical connection.
Oh,
Yeah, you
yeah.
can see the outflow channel is in the right exit region of, the right
Can you
entrance
talk
region.
about that trough?
Yeah.
Yeah,
Trough
yeah,
on that
yeah.
area.
Yeah. Yeah, so when we go to the upper level shots here, we'll take a look not only at today, but also the evolution over the week. There's some interesting things that, yeah, that's for sure.
Greg was saying that Ian's jet is setting up potentially a Mediterranean significant event.
I didn't look that far east, so that's interesting. Yeah, I didn't look that far east. I'm sure that's the case. And Ian Beckley had the notion today that this starts to take on an extratropical look to it and drier air in this location, and still probably some vertical shear that is acting across this moisture gradient, and that can help to intensify the convective potential over southeastern and central North Carolina because you change the slope of moist isotropes differentially without doing anything to the mass, and that makes it less convectively stable. So that's true, that's a possibility in this case, I suppose. But one would have to know the details of the shear and the gradient of moisture along the leading edge of that shear, and the equivalent being the dry slot in extratropical cyclones, which is a spot that's well known to foster greater convective potential under the right circumstances. So don't see it, at least in the cloud tops, but I don't know yet, actually widely spread. It's not clearly evident, but it might be occurring in the radar reflectivity.
I think you'll go to the jet level later, but it's really closely connected to the tropical cyclone outflow.
Yeah.
Yeah, and we're kind of mentioning that with respect to the satellite right now. There's a very sharp edge to it, and that's probably the jet axis. So you can kind of see that there's a sharp edge to that outflow even now, but earlier in the week it was even more obviously right along the coast. So we'll visit that. So looking at this broad satellite picture, thanks Pete, you read my mind. I wanted to go here next anyway, just to get the complexion of the flow around the whole western hemisphere, or a large part of it. What's been very interesting, taking slight attention away from Ian all week long, has been a fairly active Canadian cyclone track this week, and one of those has developed into a fairly intense disturbance. It's now residing in the sort of central Labrador Sea, but look at all the cold air advection that you can see evident coming off of Hudson Bay, which is not ice covered yet. And so tremendous amount of stratocumulus coming off the relatively warm. Imagine saying Hudson Bay is relatively warm. It testifies to how cold this air is. It's very cold. And then there's a very sharp boundary to the leading edge of that cold air, and we'll see that manifest in isotherms at 850 and thickness lines from 1,000 to 500. And so this is an active period of weather across most of Canada. There's also a really interesting cyclonic disturbance here over far western Montana, northeastern Idaho, and that's clearly tied to an upper level feature that's coming off the Pacific over a couple of days. It's one of maybe the first in a series of leading events at lower latitude that are going to be manifesting themselves on the map. And then the flow tends to, appears anyway, to undergo a period of relaxation across North America until early next week, when it kind of gets high amplitude again. So there's been a lot of fluctuation between high amplitude flow, kind of more zonally oriented flow, and then a return later on next week to high amplitude flow. Very interesting. And well, I'll show you some artifacts of the high amplitude flow that was over us this week. One of them, of course, is the cool temperatures. These are unusually cold temperatures. I think we had 35 overnight at the airport, which is the coldest temperature of the month, and it rivals the coldest September 29th we've ever had. So that's interesting. Okay, and then this is Nodine, I think, or something. What's that the name of it, Isaac? What is it, Ordine? It's something.
Orlean, yeah.
Orlean? Like not new, but Orlean? Okay. So there's a storm, and yesterday it was just a tropical storm. I don't know what it is now. I didn't look, but I will.
It's still a tropical storm.
It's still a tropical storm? Okay. So that's a pretty decent tropical storm. Bella and Layla told us about that yesterday in 452. So that's the complexion. Plenty of cold air aloft, or north of us, I should say, and that's going to, gradually sag southward. We have a really big cold air outbreak on our doorstep coming up middle to late next week, which we'll talk a little bit about in just a minute. And then always, I like to keep my eyes on the lake. There's a really nice lake parallel band, axis parallel band, all the way from the northern part of Lake Michigan down to Chicago this morning. Probably not precipitating. I don't think it shows up in the reflectivity, but it's nonetheless would be a really cool thing to see from the shore. Look out there and see it. Okay, and always, these are like boiling pots of water right now when you get this kind of air just moving a little further to the north, so
You see the
things can
fog
get
out here
interesting fast.
yesterday and today?
Yeah, and last
Lakes
night,
especially.
Wednesday night, we were coming back from Spring Green. My wife and I went out to see a play, and it was around 11 o'clock by the time it's all done and you're driving back. And there's these little pockets of fog that you drive through on Highway 12 or 14. It was really awesome, So that was cool. She didn't like it. She's driving, but I liked it. So, let's take a look at the radar summary, Pete.
I was gonna pull this up real quick. This is the.
Oh, very nice.
Yeah.
This is looking at the south from the rooftop cameras.
That's nice. This is nothing. Wait till we get a cold air outbreak when there's no ice on the lake. Myra especially, I'm gonna come up to your office and drag you up to the roof. Because we can get steam devils on days like that. And they can be 300 feet high, and you can watch them traipse across the lake. It is
Oh, that's
awesome.
amazing.
It's-
I got some of that in my apartment too.
Oh, yeah?
Two days ago.
Yeah.
2 days ago. Or yesterday, actually, yesterday. It felt like walking the clouds.
Yeah, it's awesome to see these things. It's one of the greatest things about the cold season around here. Okay, here's the reflectivity. So we can see Ian making its, well, it looks to me like it's making landfall right at Charleston, which was yesterday's forecast, so good for the NHC. And then widespread, mostly heavy precipitation, a couple of gaps, and that shows up, didn't it, in the accumulated forecast in central North Carolina. It seemed like the Raleigh-Durham area wouldn't get as much as places to its northeast or to its southwest, and that is evident. That's amazing, okay? Quit complaining about these forecasts, they're so good. And so even raining into Washington, D.C. As we speak. So Michael gets a little bit of attention from Hurricane Ian, so good for him. So light precipitation across the Dakotas and into southwestern Minnesota. We didn't really investigate your question the other day in the weather discussion. I don't know what's going on there. Maybe we'll try to make sense of that in a minute. And here's the broader cyclonic circulation, the elements of precipitation being carried along in that circulation over western Montana. And we'll be able to say something intelligent about that, I'm quite sure. So let's take a look now at some upper level charts, Pete. Start at 500 millibars with the, what is the word, eponymous super Pete. We want to look at that. So here's our 12Z map from this morning, and there's the 500 millibar manifestation of Ian. It's you can see it's struggling to be a warm core at 500. It's not as obvious as some of the other tropical storms we've seen in the last couple of weeks, but it's undergone substantial weakening in a short period of re-intensification. But that still looks like a pretty decent signal there. Broadly speaking, evidence of a prior high amplitude flow over the western part of the United States and eastern Pacific, and then a fairly zonal flow with a couple of waves over the archipelago and one over in northeastern Canada. Here's a big cyclone on the northeast side of Hudson Bay and a decent baroclinic zone, even at 500 millibars, stretching across the southern part of the bay. And then here's the upper level cyclone appearing, it's just about to completely cut off, it appears, over Montana, Idaho. And so just to the east of that, this is a region where you have upper level divergence, column stretching, and vorticity production. And if the air is cooling because it's rising, you can produce clouds and precipitation, and they can show you where it's rotating cyclonically in the radar or in the satellite pictures. We've seen in both cases. Okay? And then broadly, over the whole southeastern Pacific, bordering California, and then the southwestern states, almost no flow at 3 miles above the ground. Really boring flow there. So everything's happening at higher latitudes across North America and adjacent waters, especially to the west. I think it's interesting to show this, Pete, if we look at a movie of this for several of the days prior to now. So let's do that. Let's take a look at the loop, and thank you for providing it. So here's our high amplitude flow on Monday morning. Look at how high amplitude this trough is. Meanwhile, Ian's trying to get itself out of the Caribbean. And so this is a decent looking upper trough off the west coast, but this is an enormous upper level trough over us, and we're in the northwesterly flow. If this were January 26th instead of September 26th, nobody would leave their homes. Okay, this is brutally cold potential. And then right here over Lake, the Great Slave Lake, and I forget the name of the smaller one, in the Northwest Territories, Yukon area, there's a really decent horizontal temperature contrast here. And this is characterized by decent shear across at 50 knots at that station, 75 over here. And so this is a place to watch out for the development of an upper level front. So let's just click through this. Look at how that flow, that portion of the flow becomes almost perfectly northwesterly. Go again. And look at how the temperature contrast is intensifying over Lake Winnipeg in southern Manitoba. So that's 75 knots there and only 45 at Lake of the Woods, Minnesota, northern part of Minnesota. So that's a strong upper front that's developing. We're going to look at it one more time. We're going to look at it in Vis 5D at this time right here. And look at how sharp that horizontal temperature contrast has gotten. Minus 27 over Chicago at 500 millibars. And it's on the order of something like minus 10 across St. Louis. So that over the, 2/3 of the state of Illinois, a 17-degree temperature contrast, 100 knots at Davenport at 500 millibars, 95 at Lincoln, Illinois. So extraordinary wind speeds embedded sort of within that horizontal temperature contrast region, and then 5 knots, a zephyr at Green Bay in minus 26 there. So a really sharp upper level frontal feature. We haven't talked about these in 452, but we will. Ian's emerging out of the tropics at this time, or towards Florida. Let's keep going. Here's our upper frontal structure and probably a significant upper vorticity feature. It's by this time, which is now Thursday morning, Wednesday night. It's over Virginia, southern Pennsylvania, and you can see 90 knots, no 100 knots anymore at 500 millibars. And that's just poor timing. It's not going to be associated with any extratropical redevelopment of Ian. However, it provides a really strong region of anticyclonic shear. Here's the jet core in the middle of this geopotential height gradient region. So on the anticyclonic or eastern side of that, that's a great place to dispose of air that you're sucking out of the boundary layer. It's easy to throw it horizontally away from you when their relative vorticity is negative. And so this is what you saw all week long in the satellite picture was as Ian approached Florida, that cloud streak was going straight up the coast along this so-called outflow channel. And that outflow channel has an important characteristic, that is the relative vorticity is negative, and you can push air around with ease without resistance in that case. But this is a broad upper trough, and it's easy to see why, with its progression across us by Wednesday night, why this has been a chilly week. And then we have this ridge in between that ensures surface-based anticyclonic conditions. You can't ask for a better place to have upper-level convergence than downstream of the ridge axis and upstream of the trough axis. As strong as upper convergence and subsidence can be, it was over us on Wednesday and Thursday, and we had beautiful clear skies as a testament to that. And at the same time, here's the first of several little waves that are going to come along. This is the one that is currently over Montana, Idaho, but on Wednesday night was offshore of the Pacific Northwest. We click through a couple more times, and you can see that feature make its way inland. And now one more would be yesterday, this morning. Yesterday, sorry. And that was when the feature was just beginning to show up as a cyclonic cloud and precipitation feature in western Montana. So a nice relationship there. And there's the crashing of this fairly substantial wave at very high latitude over the Canadian archipelago with another strong baroclinic zone. We're going to look at that just momentarily at other levels. That's a well-developed cyclone. And then we are back to our current time. So let's take a look at 300 millibars, Pete, and just at the current time. We won't do the whole movie. 500 suffices to give an idea of the complexion of that. So here's our 12Z 300 millibar analysis. The entire continental United States is just about devoid of winds at 300 millibars above 90 knots. There's one exception here at Islip, New York, and a couple in the western states, Oregon, and parts of Nevada. Other than that, all of the high wind speed action is at higher latitude. This plume of 153 or so knots that's kind of grazing Iceland maybe at this time, that is partly an artifact of the convective outflow of Ian. But it was already there to begin with, so it's a combination of the two. Okay, and then one other thing I wanted to show. Let's see if there's any semblance of a subtropical jet by going to 200 millibars. None. So what a great week for the tropics. If you want to develop some kind of disturbance like Ian, this is a perfect environment in which to do it. The shear from 200 millibars, where the winds are really weak, to 850 is probably almost zero. And what's it going to be, below 15 to really, or maybe below 10 to keep those things preserved from the extremely toxic environment that vertical shear provides to tropical cyclones. All of the jet activity is at higher latitude, none of it in this part of the hemisphere in the subtropics. Okay, let's, can we go to, 850, I want to see the thermal structure at 850. So here's our storm over northeastern Hudson Bay, and you can see this really strong cold frontal baroclinic zone that links back to yet another disturbance on the north slope of Alaska that will have something to say about our weather as we move towards the middle of next week. There's Ian, and it's, again, a bit of a warm core disturbance. It's not exactly concentric with the geopotential height lines like sometimes these storms can appear. Not in this case. We've already seen it's a little dilapidated, maybe disjointed in the verticals to some degree, and that's reflected a little bit in that misfit between where the warm core is and where the lowest geopotential height is. Although part of that is just analysis error too, perhaps. So this is a very interesting cyclone on the southern edge of it. Of course, it's this cold front. That's where we saw that cloud band, and north of which we had all the stratocumulus in the cold advection region. So that really tells you where that cold front with this Canadian cyclone is, and we have to watch for what happens with this one here, because it's got plenty of baroclinicity, a nice baroclinic zone to its east, and something that will emerge from the high terrain of the Yukon and Alaska that will also show up nicely as that storm evolves. Okay, two more things that I want to do. One, of course, directly involves a forecast. The other is a bit of a departure from that. I want to look at the Vis 5D if we can, Pete, which is lurking in the background. Because one of the things that I mentioned in the survey of the 500 millibar maps for the week was the strong upper level front over us on Tuesday into Wednesday morning. So here I decided to get the Tuesday 0Z run of the GFS and put it over North America. And so I'm looking at the isobars at about 5.4 kilometers. So these are approximately 500 millibars. Here's the 500 millibar isobar right there. So they're every 4. So I'm looking at something that's like the 500 millibar surface. And then theta at the same level is in red. And this is at 0Z on Tuesday. So in the northwesterly flow over Lake Winnipeg, that's where you have your strongest horizontal temperature contrast. And there's a little bit of geostrophic cold advection in the region of cyclonic shear is enough to stop the upper front process for reasons that I think we'll talk about more if you don't give it. If I'm always giving the talk, I'm going to talk about it every week in the wintertime. I can promise you that because I find it so interesting. But if not, there can be other topics. So this is a region of interest for me. Let's click forward a couple of times. And I'll take the trajectories off. That's icing on the cake. Thanks, Pete. We'll do that later. But you can see the horizontal theta contrast getting more intense across Minnesota. 2 more clicks maybe. And then 1 more. And there's our cold pool where we saw it was minus 26 at Green Bay. Look at how sharp that horizontal temperature contrast is across Iowa, Illinois, parts of Minnesota, even into Indiana. Now, mind the time. This is Tuesday morning. We had a beautiful, clear sky day on Tuesday. And I told everybody in 452 there's something really interesting going on overhead, and you see absolutely no evidence of it. No clouds, no nothing. And if you were flying in a jet plane with a destination from Minneapolis to Lexington, you might find, why are we going so fast? You know, there'd be some evidence of why there's something there, but otherwise there isn't. So let's take a look at some cross sections of theta first. I think it goes right. Let's go back a couple times. I wanted to make sure I was at the right time. 1 more. I think that's it. Theta first. Let's flip it up, and we can get rid of the horizontal maps while we do that, so that all you see is the one of interest. So that's what the potential temperature looks like every 3 degrees Kelvin. Look at that sharp horizontal temperature contrast sticking down from the tropopause. And it's isolated. It's only in one spot, and it does not have fingers all the way down to the ground. So it's confined to the middle and upper troposphere. Okay? And then there's really interesting here in the lower stratosphere. That's a front too. Don't neglect that. That's a front. And then let's take a look at the PV. Every 1 PV unit. Look at that. This is the potential vorticity sticking right down from the tropopause stratosphere level. Thank you, Pete, all by itself. And you can see the overlap. So that's an isolated upper vortex feature. If you're at this elevation, right there, let me get my hand on it, right? And take the theta off again, Pete. If you're at that elevation, the only vortex in town is right there along that cross section. And it's a strong upper vortex. Okay? And then we put theta back on. Then let's take a look at where the vertical motions are, W. This is where I think I had a disjoint from what I wanted to show, but can we just check that that's on the same line? I think it is. Yeah, it is. Okay, it doesn't look as good at this time as it does at a later time, but that's okay because I have the later time ready. So, but these are only sinking motions, and so I'm showing you where the air is sinking at this location, and there's the sort of maximum sinking in the vicinity of the front. If we put the PV back on, that indicates that you're forcing this air that has high PV downward. In fact, at another time, we'll click ahead and move the cross-section to show it even better. You get a strong subsidence region dragging the high PV down these sloping isotropes, and that's what brings the vortex substance into the middle troposphere. This one is wasted, doesn't do anything, but they don't all get wasted. So, but it's a nice structure. And then let's put, what was the other thing I had on here? Speed. Let's take omega off and put the speed on there. And so there's the jet core. 30, 40, 50, 60, 70 meter per second jet core, right where the upper front is. Just a beautiful relationship. Put omega back on, Pete, and you see the subsidence is right through the core of the jet. That's characteristic in the development of these upper fronts for reasons that take a little more explanation, but they're discernible, okay? So that's what it looks like upstream of us in time and space. Let's go back to the top and put the pressure and theta back on. And then let's keep marching forward. So here's our, I think the next one is the one where I had the cold pool over Green Bay. So it's a pretty intense structure. Let's keep going. And it looks like that's really intense right there. I think maybe it's this time. Can you put on the theta prime cross-section? I guess it's the time prior, so click back one time. Yeah, then I drew it through here. So we're just trying to see what does this thing look like at this time. So let's see what theta looks like on that cross-section. This is now 9 o'clock in the morning, approximately, something like that, on Tuesday. So there's our upper front. Extremely strong horizontal temperature contrast. It dissipates below this level. There's nothing to it below there. And then the stratospheric, lower stratospheric front's really strong. Let's put the PV on there. Look at that. Same depression of the PV locally in one spot along the front. Let's put the W on there. Look at that. I'll take the PV off, you can see it better. There's strong subsidence right on the warm edge of this baroclinic zone. That's going to force it. And there's strong subsidence in the lower stratosphere. What's that doing to these theta lines? It's making them go more like that, which increases the horizontal contrast and temperature in the lower stratosphere. So the same subsidence simultaneously creates an upper front in the upper troposphere and one in the lower stratosphere, which is very cool. Okay? And how about speed? Wow, the subsidence is right through the core of the jet again. And we're at 30, 40, 50, 60 meter per second core of the jet at this time. And right in the PV, gradient in the horizontal is where the jet core is as well. So it's a really nice example of an upper front. Early in the season, they get stronger and more beautiful as they get stronger, as the cold season revs up. But look at the difference in the height of the tropopause. This is the cold side of the baroclinic zone. Tropopause is here. Here's the warm side. In late September, that's a big jump. And the tropopause gets folded right where the upper front is. But that's a really big jump in the tropopause height. And it has ramifications for the jet speed. And you can see where the gradient of the tropopause height is maximized is where the jet core is. So very cool. I just wanted to show you that because I thought it was such a neat example of an early season upper front. Now let's go to the forecast. And to do that, can we go to the Alicia Bentley maps? Oh, I put them up there, didn't I? I don't know where they went. Oh, that's the first thing. All you gotta do is put AL. She must feel good about that. We came this close to getting Alicia to come to graduate school. She came on a visit, the whole thing. She's such a nice person if you've never met her. She was so scared that I would hate her when she turned down my offer of coming to graduate school. She stayed at Albany, her family's in New York State. And I said, Alicia, why would I hate you about that? I might find other reasons. No, I didn't say that. I would never do that. It's a small community. I mean, we're gonna see each other forever. So, and she's made these great products, so I feel a little bit of a special affinity for her. She's such a great person. Let's take a look at the North Pacific beat. Because surprisingly, that's where all the action comes from in our coming forecast. This is a 940 millibar cyclone sitting there in the central or western Bering Sea. It's a beast. And I don't know if anybody's out there contending with it. I hope not, because it's scary. And heavy precipitation, big winds, big waves, the whole thing, as you can tell by the nature of the sea level pressure gradient. Now, and that downstream of it is a fairly high amplitude flow. And we saw evidence of this in the 500 millibar maps just a minute ago. And up on the north slope of Alaska, as part of that high amplitude flow, there's the beginnings of a development of a cyclone. Okay, so those are the initial conditions for now. Let's go back to see what this thing came from. Oh man, yet again? a tropical cyclone of some kind. I don't know what the name of this was. I couldn't find it. You guys are better at this than me. It's probably got some hard to pronounce name or something like that, but it was south of Japan on, this is Tuesday, right, or Monday.
It's Roca.
What was it called?
Roca, R-O-K-E.
Oh, this is Roca. Oh, I didn't know that. I thought there was another one that was more powerful than this. Okay, so maybe I did see the evidence for what it was called, but I overlooked it because I thought I was looking at a different storm, a weaker one. Okay, so this is Typhoon Roca, or Tropical Storm Roca. And now, look at the initial state. Again, everything west of sort of western Alaska is pretty zonal. There's a little bit of, you know, these are 200 millibar wind speeds colored in. Pretty decent jet structures here associated with strong thicknesses and 5,500 millibar thickness. But it's more or less zonal, not high amplitude. Here's a big cyclone that's getting revved up on the western part of the Aleutians. And there's Roca sitting there wondering, what can I do to this? So let's go forward, just to remind ourselves what happens. Look at how the whole Pacific Basin at latitude 40 degrees north gets to be zonal after this. This is our high amplitude flow that got us cold this week. So that's high amplitude event number one. Keep going. And then across the Pacific, it's fairly low amplitude, though active, lots of little cyclones, but fairly low amplitude flow until Roca makes a contact with the more or less well-behaved, almost zonal jet. Let's keep going. Watch what happens. Here it goes. So there's outflow from Roca that contributes to downstream development. This jet takes on a more northwesterly orientation. The entire wavy flow is accentuated as it gets into its extratropical conversion mode. So let's keep on going, Pete. Look at that. You perturb this whole wave train, and this is going to be the main storm in the Bering Sea. Look at that. Remarkable, isn't it? And I don't know what this one is. Maybe it's going to do something similar, although it doesn't look like it has the right immediate upstream condition. So this is almost now. Let's go a little bit ahead to 12 hours. Yeah, that's now. And so we've got this big storm and a high amplitude flow, and part of the high amplitude, the consequences of the high amplitude flow here in the thickness field, very obvious, is the development of this cyclone with a warm sector to itself and colder air to the north. Now let's go to, I think, a North American view instead of the Pacific view. And we'll start from that time. I think North America does it. Let me see if I'm right. Yeah, it pretty much does it. Okay, so now we're starting from that same time. So to remind you, our main storm is 940 millibars here in the Bering Sea. Here's an example of the high amplitude flow that's been kicked up under its influence, hitting the jet. And there's our little cyclone on the north slope. And then the broad variclinicity over Canada. So let's march forward and keep our eyes on this region as we do so. So that storm kind of moves northward. A new one's going to develop in roughly the same location. Like you're beginning to see it there. And that storm then takes on some reasonably quick development as part of what's coming out of the Pacific. So let's keep going. So there's a nice looking storm with a beautiful thermal structure. It's taking advantage of the variclinicity left behind in Canada. Watch the anticyclone though, and it kind of pops up out of the Yukon territories. There's the cyclone. Here comes the anticyclone, coming out of the high Arctic. Okay. I think it's this one up further to the north. Let's see. Oh, right. Yeah, it's this one here. Watch this. That's 1024, 1028. Here it comes. And we're on, it's that Tuesday, noontime Tuesday, 1032. 1032 is expanding a little bit, 1036. 1036 expands, and then it's crushing, it's coming right down over us. Look at this thickness contrast. This gets us to, we can stop here, this gets us to midnight Wednesday night, and it is going to get cold fast when this thing crashes. And so the high amplitude flow, I think associated with what was Raku and then an extratropical cyclone again in the Bering Sea, kicks this whole thing up. One of the consequences is really deep anticyclone. 1036 in September, early October is unusually strong and extremely strong variclinicity. And with northerly flow, we are going to get very cold. This is now midnight on Thursday, so Thursday day is going to be really cold relative to normal around here, very cold, and probably rainy in the beginning of the day. So if we keep clicking forward, Pete, you can see those thicknesses get below 540 over us. That's the first blue contour. And northerly flow remains a little weaker maybe by the time we get to late in the day, Thursday, but 540 becomes 532 or something like that. So this is not really that long a forecast. It's 1 week away, and we're talking about some really unprecedentedly cold air for so far this year, even though we had a cold end of September. So I think a connection could be drawn between that tropical event, the extratropical conversion that it makes, and then the reestablishment of really high amplitude flow over the western part of North America that gives us our first really legitimate cold air outbreak Wednesday night into Thursday, and it'll stay around, all day Thursday. It's going to be chilly. And I'll give you, on your own time, you can take a look at how tropical Tidbits or some of the other places in Pete's maps color in 850 millibar temperatures as well, and they're really nice to look at. You can see how widespread this cold below -5 air is going to be at 850 over the Great Lakes states on Thursday. So it's going to be downright cold around here on Thursday next week, it looks like. So until then, though, the forecast calls for it being precipitation free, I think, for the most part, and relatively warm, not unseasonably warm, and with cool nights, just what you want at this time of year, but really cold mid to late next week for a couple of days. So that's what I have for today. Any comments or questions?
Point out, if you click back to right where this flow starts to amplify, there's almost like a shear line trough. It's sort of it's like a trip bus folded in its own right, and you can see the jet.
Where are you?
Keep going way back, Pete. See the cutoff there, so keep going until you see the trough that came from. Keep going. Yep. Keep going. Right there, you see the jet completely.
Where?
Going right at the tip of the cutoff of the cold air. So there's the pinch trough, the two jets straddling.
Oh, this here?
Yeah, and then at the very bottom of the northerly flow, it's overriding all the thickness contours, and it's not the right product for the job, but you can imagine that's a spot of cold air advection.
Oh, it might be, yeah, it might be, yeah. Well, it certainly is, 1,000 millibar isobars look like the sea level isobars, and then the 1,500 thickness accomplished by the advection of 500 to 1,000 thickness by the 1,000 millibar isobars is the same as 500 millibar advection of the thicknesses. They're identical. So that is evidence of cold advection a lot, probably.
Like a smash up between a high pressure system to the west and the low, and there's still northerly flow. There's cold air advection right
Yeah,
up the
yeah.
that. That's going to be a cutoff. Like if you see that, it's always going to be a cutoff.
Yeah, very often that's the case.
I thought that was pretty cool.
Yeah. Any other comments or questions? Okay, thank you, Pete, again for expert driving through Vis5D and all that and all these other products. Thank you for your attention, and we'll see you next week. Wear a coat.